The concept of load average is a commonly used metric to determine the health and performance of a given Linux environment. This information is provided directly from the Linux kernel and gives us a snapshot in time understanding of the performance and availability of system resources over several different intervals of time. As we track the availability of system resources over time, we can understand whether or not performance is degrading or improving, and further go on to track down which processes may be causing this change in behavior. Every 5 seconds, the kernel gathers the concept of a number it calls the load number. This load number is based on a calculation on the number of running processes as well as those that are in uninterruptible states. It accumulates this concept and does calculations to provide us a health report on the load number in the given 1 minute ago, 5 minute ago, and 15 minute ago increments. It's in this fashion, by tracking the trend of that number over these intervals of time of 1, 5, and 15 minutes, that we can determine if a system is improving its performance or degrading in its performance. Remember, the terms are provided in these specific time intervals: 1, 5, and 15 minutes ago. So understanding what the load average calculation is can be a bit complex or puzzling to individuals. You can take for granted that this information is valuable, certainly, but understanding how it's calculated provides a little more insight as to what value it provides. The load average is calculated by the kernel, determining how many processes are ready to run on the CPU versus how many processes are waiting to enter this state. It's essentially a ratio between the processes in the running or runnable state and those that are in a waiting to run state, determining whether or not the system is available to take on more or less work. Depending on your environment, this calculation may vary on what specific information loads into the number. However, the trend over time is an important heuristic for a system administrator to understand degrading or improving health of a system. In general, the determination from a load average allows us to understand how healthy a system is, whether it can take on more processes and provide more work currently, or if it's being taxed to a point of near breaking by the amount of workloads that are currently requested for the CPU and resources. Load averages are displayed in a delayed fashion in those time intervals of 1 minute, 5 minutes, and 15 minutes ago. So we're always doing a look back on system performance. If system performance numbers are getting better at the 1 minute time than they were 15 minutes ago, we can assume that the system is recovering or trending in a more healthy direction. However, if 15 minutes ago the load average was in a better situation than it was 1 minute ago, we can understand that the system is in a degrading health. As we look at those three values over time, we can then make assumptions about the behavior of the system and determine what other remediation may be necessary. Let's take a look at a specific output of the command uptime, which is one way to display the current load average. The command uptime displays the current load average and provides us with output that looks something like that in the box. The main point of uptime is to show the information for how long the current boot of the system has been going on. In this case, it shows an uptime of 14 minutes in this sample output. It also shows how many users are currently connected to the system. The information we'd like to focus on here is the load average. Remember that these are shown in the last 1, 5, and 15 minute intervals. Here we can see that the load average 15 minutes ago, a much higher number of 5.2, shows a more heavily taxed system than it was 1 minute ago. The load average 1 minute ago, showing 2.92, shows that we have more system resources available since the number is lower. This means that 15 minutes ago our system was much busier, almost twice as busy as it is currently. We can make an assumption that this trend shows that the system is becoming more available or in a healthier state to take on more work currently than it was 15 minutes ago. By interpreting these numbers over time, we can make those assumptions in a safe fashion about the system environment. When we start looking into what may be causing system bog down or what other processes may be in play, we can start using other commands to gather information about the system and calculate things like available CPU load. We have a helpful command called lscpu, which will determine how many CPUs the system has, as well as critical information about those specific CPUs. You can take a look at the output of the lscpu command here. Namely, what most people want to gather out of this, at least when doing this kind of inspection, is how many CPUs am I working with on this given system? In this sample output, we're looking at a Linux system that has 4 CPUs available. That means that we have 4 different processors that are available for scheduling process jobs. When we start interpreting load averages based on the number of CPUs available to us, we can think of the number of CPUs as a multiplier on this available work that the system can perform. While it's not exactly 1-to-1, we can take a consideration that one CPU can provide a load average of 1 amount of work at a time. In this way, a system with 4 CPUs should be very comfortable running at a load average of 4. Numbers greater than 4 could indicate an issue with system availability and resources, while a number less than 4 means that we have available CPU processing power available to us to do more work. While this isn't a hard and fast rule, it's a great rule of thumb in order to determine a proper load average for a given Linux environment. Other tools that report load average are things like the command W and top. We've taken a look at these briefly, but let's jump in a terminal and just see where load average exists given these commands. If we type the command W, we can see that load average is clearly displayed here. Additionally, if we use the command top, load average is also output at the beginning of its output. I apologize for line wrap, but we can see the output of the load average here as well. That concludes our section on describing the load average.